Okay, to start the intro to truth tables, and we're just going to do an intro to truth tables, we need to go back to really things that we learned in chapter 2 and pull some things together and remind us of a few things. So go through these with me as we talk about these, and then you're going to have some things you're going to have to memorize. Not a great deal, really about four different things, but what we're doing, we're looking at statements that are true and false, and we're trying to determine if we're given a different combination of ands and ors with these true and false sentences, ultimately, is what is being said really true or is it really false? Can we play on words and twist words such that something may sound true but it may really be false? Or what are all the possible scenarios that exist about something being true or something being false? So that's what we're looking at. Remember that a statement is any sentence that's either true or false. We assign a statement a truth value. It's true or it's false. And those statements are represented by P and Q and sometimes R. We are not going any further than having a P, Q, and an R in our truth tables. Truth value simply means true or false. The sky is orange. Well, right now, as I look at the sky, it's not orange at all. It's pretty and blue, so that's a false statement. The chair is blue. Well, the chair I'm looking at right now is blue, so that has a truth value of true. A negation is the opposite of a statement. So if a statement was true, to negate that statement, it becomes false. If a statement is false and I negate it, then the statement will become true. Compound statements are two or more statements that are joined with the conjunction and or the disjunction or. Now remember, conjunction means and. When you're using conjunction with absolute values in algebra, absolute value inequalities, you use the intersect sign a lot because you want the intersection or overlap of two sets. So and is the symbol inverted V, and it's really important you know that symbol because we're going to be using it. And the disjunction is the union of two sets or two sets. So these two symbols are very critical that you know. Again, a conditional statement is an if-then statement. If you have one counterexample to an if-then statement, then that makes the entire statement false. The hypothesis is the antecedent, the first part, the part behind the if. Okay? It's the condition that must be met before a certain action occurs. We used this statement at the beginning of the year. If it rains, then I'll carry an umbrella. It rains is the hypotenuse. I'll carry hypotenuse. I've just been doing a video about right triangles for somebody. It rains is the hypothesis. And then the conclusion of my sentence is I'll carry an umbrella. Okay? Remember, when we flip those around, when we have the P implies Q, and we flip around and put the conclusion first, if I carry an umbrella, then it will rain. This is called the converse of the statement. If I go back to my original statement and negate both parts, I have formed the inverse of the statement. And if I negate both parts and flip, that's called the contrapositive of the statement. Remember that the statement itself and the contrapositive always have the same truth value, and the converse and the inverse always have the same truth value. And the last thing I want to remind us of is that a biconditional is an if and only if statement, and I'm going to talk about that a little bit more, so I'm going to put that a little bit more later, so I'm going to put that off because I want us to kind of get into seeing some truth tables. And again, the reason I wanted to go back and do this is because the students that I had last year said that this helped them in the early stages of their coding class, some of them, so I wanted to make sure that you had the same exposure that they had. Okay, first thing I'm going to do is make the easiest little truth table that I possibly can, just to show you what a truth table is like. So obviously we will draw a little table. And most of the time we will have a P and a Q, but for the one I'm going to show you now, we're just going to have a P. Okay? So the statement has been, whatever the statement is, it has symbolically been called P. Any statement in the world, symbolically we're calling it P. Now that statement can either be true or it could be false. Okay? It could be true, it could be false. So if I want to say, okay, then what would not P mean? Well, I'm going to look at the P column and take the opposite of everything I see. So whereas P is true, not P is false. Whereas P is false, not P would be true. So this is my negation, and how I perform a negation by using the very most basic little truth table. Okay? Now, the next two truth tables I want to show you, you're going to have to memorize. So we're going to use P and Q this time, and this is more like we're going to see from here on out. Okay? Now, when I make a truth table, I'm going to put P in the first column and Q in the second, and if I had an R, I'd put it in the third column. Again, we're going to do that later. Then I'm going to put all the possible combinations of truth values that I can come up with. Well, my P, I'm going to always have true, true, false, false. Okay, so half will be true and half will be false. Then in my last column for statements, I'm going to just always alternate. True, false, true, false. Those are all possible combinations of true and false for the statements P and Q. They could both be true or both be false. The first one could be true and the second one false, or the first one false and the second one true. Okay, so that's always what we start with. Now, after that, this row is going to tell us something to do with those P's and Q's, either to negate, to disjunct them, or to conjunct them. On this one, we're going to do the conjunction, and this is one that you're going to have to memorize. So my column up here at the top tells me what I'm going to do. I'm going to put those together with a conjunction. That's what my symbol means, remember? P and Q is what this says. P and Q. Well, the truth assignments for conjuncting these values, again, you have to memorize that true and true will always give you true. But anytime there's a false involved, it's going to make everything false. So anytime you P and Q, two trues, you get a true. When you P and Q any other combination, you get a false. Let's look at the disjunction. Whoops. Make my truth table. I'm going to disjunct two things. I always start with P and Q. P, let's get my grid here first. P is always true, true, false, false. And then the last is always true, false, true, false. You always alternate those so that I have every possible combination. Now this time I'm going to disjunct P and Q. What if I have P or Q? How do the truth values fall? Well, with P or Q, false, false gives me false. Everything else will always be true. And you're just going to have to memorize these for right now, especially at this time of the year, which I always hate to say that at the end of the year. But unfortunately, that's just the way that it is. Okay, so I think the negation is easy because those are just the opposites. But with my conjunction, if you can just remember, true, true gives you true, everything else is false. And with the disjunction, false, false gives you false, everything else is true. That's sort of how I keep those straight when I'm doing truth tables. Okay, now let's look at if we have a conditional statement. Well, we don't want to do that, do we? So I'm going to make my grid. Always start with P and Q. Half are true, half are false. Then we alternate. This time, P implies Q. How does that play out in logic with truth relationships? Well, when P implies Q, a true thing cannot imply a false thing. That's false. Everything else is said to be true. Okay, so I think that is your easiest way to remember these. I'm trying to decide why did I put that through there. I don't know. But true cannot imply false. This is your exception to the rule. I'm trying to flag all those exceptions. I can't erase that highlighter, I don't think, or it's going to erase. No, it's going to erase my. Or maybe it will. There we go. So what I should have highlighted was that line right there. Okay? So conjunction, true, true gives you true, everything else is false. Disjunction, false, false gives you false, everything else is true. Conditional, true implying false is false, everything else is true. Now with that in mind, I want to build a truth table with you, and I'll give you what we're going to build. Let's see here. Okay, so I'm going to give you this problem and tell you to make a truth table for the following. Okay, we're going to have not P or Q. And I want to know the possible truth values for a statement, a negation of one or the affirmative of the other. So let's look at our possibilities. Let's draw our box with our table. Always begin this way. And I'm going to have P and Q always to begin with. Half are true, half are false. Alternate. Now, I look at what I have up here. I have a not P being used. So I've got to have a column for not P. Then I've got a not P disjuncted with Q. So this is how I'm going to do my truth table. Okay, for not P, I'm going to look at the P column, and I'm going to take the opposite of that column. So I'm going to have false, false, true, true. Now I'm supposed to disjunct not P and Q. So I'm going to be looking at these combinations and remembering what we said about a disjunction. With a disjunction, false, false is false, everything else is true. So I like to go down and look at my combinations, and I see here false, false is false. I don't even look at the other combinations. I just know that the rest of them have to be true. Now, if I have all of these columns turn out to be true, if they all turn out to be true, which in this case they don't, but if they do, then I have what's called a mathematical tautology. Okay? Sometimes you're given two expressions like this and asked to see if they are logically equivalent. So I may ask you to do two truth tables and say, is P disjuncted with Q logically equivalent and then give you another something, maybe P or not Q or something like that. And you would do a truth table for both and see if the last lines of your truth table, those last columns, were identical to each other. Now I'm going to do another truth table or two with you, and then that's where I want to leave it for now, so that we can pick up after the chapter 12 test. So I'm going to turn the page and give us another truth table to complete. Okay, let's say we're going to be given not P and not Q, and we're going to disjunct that with Q. Okay? So let me show you how we'll do this. We're going to have a little bit bigger table this time. Our first two columns we should know quite well by now. P and Q. If there were an R up there, my third column will be R, but there's not. Okay? So we always true, true, false, false, and then alternate true, false, true, false. That's always the way we begin. Then we look at what we have up in our problem. I have a not P, so I need a column for not P. Not P, I go to the P column and I negate everything. False, false, true, true. I have a not Q, so I need to make a not Q column. So we'll look at the Q column and I negate everything. False, true, false, true. Now the next thing I have to do is what the parenthesis says. I've got a conjunction here. So it says look at the not P column and the not Q column and perform the conjunction, because this symbol means conjunction. It's an and. Well, if you remember, what you have to memorize, the conjunction is true, true is true. Everything else is false. So as I look at these two columns and I'm performing the disjunction, true, true is true. Everything else is false. Now the last column tells me to take what I get from the not P conjunct not Q column and disjunct it with the Q column. So I'm going to look at this column and I'm going to perform the disjunction with the Q column. Now remember, the disjunction, the or, is false, false, false. Everything else is true. So as I look down through here, the second row is a false, false, so it must be false. All other combinations are true. So there's my truth table. It is not a mathematical tautology, which means it's not always true. Okay? So my statement, if my statements are not statement and a not statement, or the positive of a statement, then everything is true unless that this condition right here, across here, exists. Now, I wish we had time for me to put a lot of statements in there. Maybe we will. It depends on how y'all catch on to this. But these can be a lot of fun. It just takes some memorizing and then just sort of completing the puzzle. I'm going to do one more with you and see how that one goes. I think I'll get a clean page. Okay, let's say, and I'm just making these up, okay? Let's say we've got P implies not Q or not P. Okay, so we make our chart. We always have our P and our Q. The first is always half trues, half false. The last one is true, false, true, false. Okay, now let's see what other things we have to come up with here. We have to have a not Q column. We have to have a not P column. We have to have a not Q or not P column. And then we have to have our implication column. Let's see how this goes. Okay, so to get from Q to not Q, we negate everything in the Q row. Then I'm going to negate my P, so that's going to become false, false, true, true. Then this column tells me that's an or is disjunction, so false, false is false. Everything else is true. So as I look at these two together, false, false is false. Everything else is true. Now remember, in my implication, this implies that what is false there is if a true implies a false, then that's false. Any other combination we consider true. So I've got to look at the P column. So I'm going to look at this column, implying this column. So if I have a true going to a false, then I have a false statement. We'll look at the first one. True, false. I know that's false. True, true is true. False, true is true. False, true is true. So my last column there, I have false, true, true, false. I do not have a tautology that is not true all the time. It is, in some instances, 3/4 of the time, but not always. I hope I've done enough to get you started on some of the simple ones. Like I said, we haven't done the biconditionals yet. I want to do that a little later. And I want to add the third column, the R, a little bit later. But we want to practice on the next time I see you, we want to practice doing these tautologies and these possible combinations.